Geometry class, what's going on? We're going to do the area of non-rigid transformations. And if you recall, and I can't remember exactly what chapter, but it says it right here. It says in chapter 7. Um, in chapter 7, when we talked about similar figures, you had a triangle like this, and then you had a bigger triangle like that. And let's say that this base was 2 and this corresponding base was 4, just to make it easy. You can see that our scale factor, when you compare this to this, the scale factor is going to be 2, right? It's twice as big. So the perimeter of this figure is going to be twice as much as this figure. It's basically proportional to the scale factor. When we talk about area, there's also going to be a corresponding proportion, but the deal is think about, let's see, how can I explain this? It's maybe easiest if I do a rectangle. If this rectangle, so let's just do this is 1.5 and this is 3, just because I'm so uncreative and I'm going up by 2. So we know that the perimeter of this is going to be twice as much as this. But do you see that we've increased the length of this by 2, and we've also increased the width of this by 2? And because the area, the space inside here, is going to be length times width, we're basically increasing this one by 2 times 2. So here's the deal, is the area of a similar figure is proportional to the other figure, except it's squared, to the scale factor squared. Is there a better, maybe I should say that the way they did it. It says, if two polygons are similar, this is theorem 10.1. If two polygons are similar, then their areas are proportional to the square of the scale factor between them. I think that's what I said, okay? And so let's just try using this for a second. Let's not do this one. Let's say this is 2. And so we know the area of this is going to be 3 units squared, right? So we can make a little proportion here. We know that the area of the big guy is to the area of the small guy, which we already know is 3 units squared, right? As the scale factor squared, so that's 2 squared is to 1. So this is just a simple proportion. We know this is going to be 4, right? And we're going to take this and multiply it by 4 to get the area of the big guy. So 3 times 4, last time I checked, the area of this guy is going to be 12 units squared. And you can use that in a lot of different ways, but that's the main concept, is that the areas are going to be related, but they're going to be related by the scale factor squared. All right.